Conic section. Learning objectives. At the end of this topic, you will be able to define conic section, understand the focus and directrix of the conic section, demonstrate the method for construction of parabola, construct tangent and normal to the parabola. As we are clear with objectives, let us know what are conic sections. Conic sections. Conic sections are the sections of a right circular cone obtained by cutting the cone in different ways. Depending upon the position of cutting plane relative to the axis of cone, three sections are obtained. They are as follows: ellipse, parabola, hyperbola. Parabola. A parabola is obtained when a section plane parallel to the one generators cuts the cone. Conic. A conic is defined as a locus of point moving in a plane such that the ratio of its distance from a fixed point to a fixed straight line is always constant. The fixed point is called focus and the fixed straight line is called the directrix. The ratio, distance of the point from the focus, is divided by distance of the point from the directrix is called eccentricity, A. That is, PF divided by PM is equal to eccentricity. E is equal to 1 for parabola. E is less than 1 for ellipse. E is more than 1 for hyperbola. As we are familiar with the conditions for conics, now let us see how to construct a parabola and also normal and tangent to the curve. Problem. Construct a parabola with the distance of the focus from the directrix is 50 millimeter. Also, draw normal and tangent to the curve at a point 40 millimeter from the directrix. Or, a fixed point is 50 millimeter from a fixed straight line. Draw the locus of a point P moving such a way that its distance from the fixed straight line is equal to its distance from the fixed point. Name the curve. Also, draw normal and tangent to the curve at a point 40 millimeter from the fixed straight line. The constructional procedure for the above problem is as follows. Draw the horizontal straight line. AB represents the axis of parabola. Draw the vertical straight line CD through A represents directrix of parabola. Mark the focus F on AB such that AF is equal to 50 millimeters. Locate the vertex V on AB such that AV is equal to VF is equal to 25 millimeter. Draw a line VE perpendicular to AB such that VE is equal to VF is equal to 25 millimeters. Join A and E and extend. Locate a number of points 1, 2, 3, 4 and 5 to the right of V on the axis which need not be equidistant. Through the points 1, 2, 3, 4 and 5, draw lines perpendicular to the axis and to meet the line AE extended at 1, 2, 3, 4, and 5, . With radius 1, 1 dash and center F, draw arcs above and below the axis such that it intersects the line through 1 at P1 and P1 dash. With radius 2, 2 dash, and center F, draw arcs above and below the axis such that it intersects the line through 2 at P2 and P2 dash. With radius 3, 3 dash, and center F, draw arcs above and below the axis such that it intersects the line through 3 at P3 and P3 dash. With radius 4, 4 dash, and center F, draw arcs above and below the axis such that it intersects the line through 4 at P4 and P4 dash. With radius 5, 5 dash, and center F, draw arcs above and below the axis such that it intersects the line through 5 at P5 and P5 dash. Join the points from P5 to P5 dash by a smooth curve forming the required parabola. To draw tangent and normal to the parabola, locate the point M, which is at 40 mm from the directrix. Join M to F and draw a line through F perpendicular to MF, meeting the directrix at T. The line joining T and M and extended is the tangent to the parabola. Draw a line N-N perpendicular to the tangent is the normal NN to the parabola. Summary. At the end of this topic, you have learned conic section definition, concept of eccentricity, constructional method for drawing the parabola, drawing tangent and normal to parabola.
We're going to be learning as to how a parabola can be made with the help of what you call the general method. Alright, so here is the description of the problem and here we go. Construct a parabola when the distance of the focus from the directrix is equal to 50 millimeters. Alright, so the distance of focus from the directrix. Let us say that we have a point, okay, in the form of C in the directrix line itself. This vertical line is what you call the directrix. And from this directrix, the distance of the focus is how much? 50 millimeters. So let me write it down over here. CF is equal to simply 50 millimeters. Alright, so we are supposed to draw a parabola. So first of all, let me locate this F over here. Okay, somewhere here, and here it is. And this point lies at a distance of 50 millimeters from this point C over here. Alright, next thing to be done is to locate the exact location of the vertex. Now we are speaking of a parabola. And guys, you always need to remember this. The value of eccentricity in the case of a parabola is equal to 1. Alright. Now the formula for eccentricity is distance of the point from focus divided by the distance of point from the directrix. This can also be written as when P reaches V or the vertex, the formula would become VF over VC. Okay. So the distance of point V from focus is exactly the same as distance from the directrix, because when these two values are same, both numerator and denominator will be same, the overall value of eccentricity is going to work out as 1, and that's exactly when we have to deal with this guy. That's a parabola. So what needs to be done is pretty simple. Somewhere in between, or shall I say exactly in between C and F, we're going to have to make one more point in the form of say V. Alright, so what's the next step? It's pretty simple. Now 10 millimeters away from this vertex towards the right, I'm going to be making points. Let's say 1, 2, 3, 4, 5, 6. Is that enough? Okay. Now I'm going to be making vertical lines passing through these points that I've made just now, like this. Okay, you can do so very easily with the help of a mini drafter. Alright. Now the next step is extremely important, and I would suggest you all to note this down. Okay, so you're going to have to take arcs of radii. Note this down, arcs of radii. The first arc that we're going to take is C1, second one is going to be C2, C3, and it keeps on going. Okay, and I have as many as 6 points, so we have to reach up to C6. Alright, all these arcs have to be put up taking F as the center. Alright, so what you need to do is keep one leg of your compass at C, other leg at 1, and with that much amount as the radii, and then with focus F as the center, you need to place an arc above and below on this line, vertical line passing through 1 itself. Alright, now again keep one leg of your compass at C, other leg at 2, and then with F as the center, cut an arc above, cut an arc below. Repeat the same step for C3. Okay, with F as the center, cut an arc above, cut an arc below. Then with C4 as the radius and with F as the center, cut an arc above and one below. Yeah, that's it. Then with C5 as the radius, with F as center, cut an arc above, cut an arc below. With C6 as the radius, with F as center, cut an arc above, cut an arc below. And when you join all these points, it forms a smooth curve, and this curve is very popularly known as a parabola. Let me write this down over here. Well, that's it. Now the next thing that we're going to do immediately is to have a tangent and a normal at a certain point. Now let's say this is the point where we need to place a tangent and a normal. Let's say the name of that point is P. Okay, so the first thing that we've got to do is to join this P with this F over here. Okay, let us do that, and then we need to make a line perpendicular to this PF line, something of this sort, such that this angle shall work out as how much? 90 degrees. So this can be done very easily. Okay, you can do so with the help of your mini drafter or simple protractor. Anyways, this is the point that we're going to refer to as T, and when you join T with P, you're going to have what you call as a tangent and a line perpendicular to the tangent, and also passing through point P is what you call a normal. In today's video, we're going to talk about the general method for hyperbola construction. Alright, so the first important thing is the distance of focus from the directrix has been given to us as 50 millimeters. So first of all, let me set up the framework. This vertical line over here is the directrix, and this horizontal line is the axis. Okay, the intersection point is given by C, and if you watch carefully, distance of focus from the directrix, let's say that C is a point in the directrix itself. So the distance of focus from the directrix has been given as 50 millimeters. So what essentially we can do is this: at a distance of 50 millimeters, let me put up the focus F over here. Okay, so what's next? So we've been given this eccentricity, and guys, remember, if you try to work out this value, this is going to work out as 1.5. It is a clear indication it is greater than 1. So whenever the value of eccentricity is greater than 1, the curve that you're supposed to prepare or you're supposed to construct is in fact a hyperbola. Anyway, so we have been given E is equal to 3 over 2. So the formula for eccentricity is like this: distance of point from focus over the distance of the same point from the directrix, that is this point C. Anyways, can this be written in some other form? Well, it can be written in the vertex form also. Now, vertex is also a point in the hyperbola or a point in the curve. So the distance of point or the vertex from focus over the distance of vertex from where? From directrix. Now, you just have to do this drill. Numerator is 3 and denominator is 2. So 3 plus 2 is 5. So the distance between C and F has to be divided into 5 equal parts. So what essentially needs to be done is you need to scale. You need to keep a scale over here, and 10 millimeters apart you need to put a point, something of this sort. Let me show you this way. Alright, so that's it. Now VF, how much is VF? It's 3 units, and VC is how much? 2 units. Okay, so in order to find the position of this point V, you need to take 3 steps from focus, or you can also take 2 steps from the directrix. So 1, 2. Okay, so this point is basically where the vertex is. 2 points from the directrix, or 2 units from the directrix, or 3 units from the focus. 1, 2, 3. Either way, the vertex is gonna lie over here exactly. So that's the vertex. Now what? So the next thing to be done is to make a vertical line in the upper direction from this point V, such that VF is equal to VE. Alright, now let's move ahead. Let's join C with E, and in that process I'm going to be extending this line towards this direction. Okay, you can say northeast direction. Anyways, let's go ahead and let's put up points. Okay, let's start from here. Let's say this is point 1, and let me draw a vertical line through this point also. Here we go. Let's say this is point 2. Let's have a vertical line, and we are having point 3 exactly where the focus already is. So this is going to be point 3 and a vertical line through that. 4, 5, 6. and that's it. Now let me make points over here also. This, let us say this is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Now the time has arrived to put up arcs. Okay, so the arc that you're going to be taking up is 1 dash. Okay, then it's going to be 2 dash, then it's going to be 3 dash, and so on until we do this final 6 dash. All these arcs have to be put up taking F as the center. Let me write this down, taking F, that is focus, as the center, and you're going to have to make 2 arcs, one above while the other below. Let me show you what that exactly is. Alright, so let's begin. So keep one leg of your compass at 1 dash, other leg at 1, and then with F as the center, put an arc above and an arc below. It's that easy. Okay, again repeat the same process. Keep one leg of your compass at 2 dash, other leg at 2, and with F as the center, put an arc above and an arc below. Now repeat the same process. 3 dash, 3 as the radius, and with F as the center, cut an arc above, cut an arc below. With 4 dash, 4 as the radius, and with F as the center, cut an arc above, cut an arc below. With 5 dash as the radius, and with F as the center, cut an arc above, cut an arc below, and that's it. With 6 dash as the radius, and with F as the center, we need to cut an arc above and below. That's it. And when you join all these so-called intersection points, let me make a point over here in order to be very precise. When you join all these intersection points, you're going to have a smooth curve, which is popularly known as a hyperbola. Let me pass a curve through all these points. Well, that's it. This, my friend, is what you call a hyperbola. Alright, now the next thing to be done is to make a tangent and a normal at a specific point. Okay, let's select a point. Let's say we are having a point over here, somewhere here. That's it. Let's say the name of the point is point P. Join P with F. Okay, and you need to draw a perpendicular line with respect to PF, something of this sort. Okay, such that the angle subtended in between these two lines should work out as 90 degrees, right? And this line strikes the directrix somewhere here, and let's say that the name of this point is represented by T, and when T is joined with P, you have a tangent, and a line perpendicular to the tangent and passing through this point P itself is what you refer to as a normal.